In this video, we're going to work with two forms of the population growth model. One in terms of doubling time, called A, and the other in terms of relative growth rate, called R. In the first problem, we're given a population of squirrels was introduced 35 years ago, and biologists have observed that the population doubled every 7 years, and that the current population is 120,000. So in this case, we are given that t equals 35, a, which is the doubling time, equals 7, and n of t, which is n of 35, is equal to 120. And so now it's asking us what's the initial size of the squirrel population. In the formula, that's n sub 0, and it's the only variable that we have not been given the value of. So we're going to have 120,000 for the n of 35 equals n sub 0 times 2 to the power 35 divided by 7. And 35 divided by 7 is 5. 2 to the 5th is 32. So 32 n sub 0. And so n sub 0 itself is simply equal to 120,000 divided by 32. So 120,000 divided by 32 equals 3,750. That was the initial population of squirrels. Now we're asked to predict the population after 45 years. I'm saying 45 years because it's 10 years from the current time. And so we're going to be using t equals 35 plus 10, which equals 45. And so we are actually looking for n of t. And so our n sub 0 is 3,750 times 2 to the power 45 divided by 7. So we just have to evaluate this expression. 3,750 times 2 to the power parentheses 45 divided by 7 close. And that gives us 323,016. And now we're going to sketch the graph. You're going to see a characteristic exponential graph for base bigger than 1. We've got base 2. I'm going to count by 100,000s on the y-axis, which is for n of t, and by tens on the x-axis, which is for the time. So first of all, we have the point 0.3750, 3750. We have 35 years corresponding with 120,000. And we have 45 years corresponding with 323,016. So the curve will look like that. Let's move on to the next problem, which deals with bacteria. And excuse me while I erase this. I am re-recording and thought that I had erased all my marks, but I have not. All right. So in this case, our culture starts out with 9,000 bacteria. So that's our n sub 0. And after 1 hour, there are 10,000 bacteria. So this is our n of t. Specifically, our n of 1, since t equals 1, is 10,000. Now notice that this time we are supposed to find a function of t in the form of n sub 0 e to the rt. Now in order for this to be a function of t, we need to have a value for n sub 0, which we do, and a value for r, which we are going to have to compute. And so r is the relative growth rate. So we're going to start out first of all with the fact that we know that 10,000 will equal 9,000 e to the r times 1. 10,000 is n of 1, 9,000 is n sub 0, and t is 1. So when we divide by 9,000, we get 10/9 equals e to the r, because r times 1 is r. So when we take the natural log of both sides, we get the natural log of 10/9 equals r. And I'm sorry I wrote 10/10. So we'll find the natural log of 10/9. And I'm sorry, I used the common log. Let me start again. I should have used the natural log. Natural log of 10 divided by 9 is 0.105. So r equals 0.105, a rate of 10.5% growth. But now we're asked to actually write the function. So we write it as n of t equals 9,000 e to the 0.105 t. And now this is a function of t. And we're supposed to find the number of bacteria after 2 hours using this new function. So I can fill in that n of 2 would equal 9,000 times e to the 0.105 times 2, which would be 9,000 e to the 0.210. Going to our calculator, entering 9,000. Second natural log brings up the e to the power and 0.21. Close the parentheses. And we get 11,103, or approximately 11,100 bacteria. The last problem, excuse me, I apologize for that. So the last problem asks us, after how many years will the number of bacteria double? So when is n of t equal to 9,000 times 2, or 18,000? So we'll say 18,000 would then have to equal 9,000 times e to the 0.105 t. Dividing by 9,000, we get 2 equals e to the 0.105 t. Taking the log of both sides, we get the natural log of 2 equals 0.105 t. And t equals the natural log of 2 divided by 0.105. So natural log of 2, close that parentheses, that is a very common error, divide by 0.105, which is our r. Which is our R. And the number of years ends up to be 6.6.